Why is DePIN so hot right now?
I think it's just kind of a question of development time and the differences in complexity of different applications. That's
Okay.
kind of what's beautiful, right? That's really what's beautiful about this is that every blockchain, if they're IBC connected, have this functionality. So every blockchain can have the functionality of Jackal. We're obviously pretty excited from that side. It's like self-hosting, but the scalability of the cloud. If you want something like that with Amazon, just geo-distributed data in general for like, let's say a terabyte, you're looking at almost $200 if you want multi-region storage per month per terabyte. Jackal is doing the same thing at $8 a month per terabyte.
Welcome to the Interop. Today, my guests are Patrick Dunlop and Marston Connell. They're the co-founders of Jackal Protocol. Jackal is an interchain storage network that delivers decentralized storage to blockchains. And as far as I know, it's the only live production decentralized storage network in the IBC and Cosmos ecosystem. So I'm excited to talk about them today because I think decentralized storage is one of those use cases that's really undervalued, but is super cool and has a lot of interesting applications. Before we get started though, be sure to subscribe to get notified when new episodes drop every week. And remember, none of what we discuss here on the Interop is investment advice. And if you enjoy this content, you should stick with us. We're validated on Evmos, Quicksilver, Osmosis, and Passage. Just look for Interop in the active set. Patrick and Marston, thanks for joining me today.
No, thanks for having us, Seb. It's just really good to be here. It's always good to get a little bit of tech talk early in the morning up here in Canada. But yeah, no, really nice having us. Just so everyone knows, my name is Patrick. I'm the co-founder of the Jackal Protocol. I'm CEO of Jackal Labs, and I'll kick over to Marston.
Yeah, thanks for having us. As Patrick mentioned, I'm Marston Connell. I'm CTO of Jackal Labs and co-founder of the Jackal Protocol.
Nice. So how did you guys get interested in this problem, and how did you start Jackal to improve decentralized storage? Because it is a market or sort of a subsection of blockchain infrastructure where there are quite a few competitors. So just curious what the backstory is there.
Yeah, so we kind of started in 2021. We were working in digital forensics and investigations for law firms. We were investigating like flash loan attacks on Ethereum, basically, was our job. Back then, you couldn't really go to the police because they didn't really know what this was or what was going on. So you do a lot of stuff civilly. That being said, they would hire outside teams like us to investigate these things and track and trace. During that process of us working in digital forensics and investigations, we wanted to build this internal tool for chain of custody of digital evidence before the courts. That being said, when you build something like this, we were building it on Polygon. It said who had access to what evidence at what time, which is super important for kind of continuity of evidence before the bench. And we built it out, and then we were like, okay, now we need like a clean forensic environment in the cloud. And what does this mean? It means only one person can have access to it. It'd be super scalable, and it can inherently just plug into our application built on Polygon. So the no-brainer for us, we said, okay, blockchains, they like decentralization, sovereignty, ownership, all of these things. So we said, we'll go and use a decentralized storage layer. When we looked at what was currently on the market, it was either marketplace-based, so there was like no ownership and there was no kind of self-custody of the data that was being stored, which was really important for us. And the other thing is everything was using proof of work blockchains, so they were really slow. It was like cold storage archiving. You take a file and say, okay, I want to put this to rest for a really long time. You wouldn't want to build it as like a kind of a layer of the stack if you're building like a full stack web application. So one thing led to another, and we were building the solution for our problem. And then the solution to our problem internally kind of became something that was a lot more interesting to a lot of people. So that's kind of the story of why we ended up building something like this. Is we were looking for a solution to our problem. We started on the Secret network. We were using Filecoin for cold storage and archiving, and then we started building middleware in between. That was great, and it worked until we started to hit scalability ceilings, and we needed to alter the blockchain modules at their core. Filecoin was taking a long time to give our files back. It's up to 24 hours with the unsealing process that they have currently, and we said, do you know what? It might be ideal for us to go and build a Cosmos L1 so we can control the modules, have that sovereignty, and purpose-built an application for the use case we're looking to build. So that's kind of the spiel of kind of how we got to this situation, but that's pretty much it.
Very cool. Okay, I didn't realize that you guys were doing forensics work before How did you get
Yeah.
into that? Like, what's the story there? Like, I feel there's an interesting story there as well.
Yeah, so my father ran a private investigation or intelligence firm here in Ottawa, Canada, and I was a student at university, and he gives me a call. He's like, "Do you know anything about like Facebook?" And I said, "Yes, Dad, I know everything about Facebook." And then he's like, "Can you help me like scrape data on like so specific situation that they were having with with their legal team there, and they were trying to figure out just capturing digital evidence from from a digital medium because they're kind of back then they were used to kind of doing more like human intelligence type of things. So that was my entry. I started to learn Python. I started learning how to web scrape a little bit. And I entered there, and then I spent about 4 years at Inquisitive Intel, where we were doing all these forensics things, and it turned more into a digital shop. Marston came on board with us there, and that's how me and Marston met originally. And I'll kick it over to Marston for his entry to Inquisitive Intel and the digital forensics realm.
Yeah, for sure. Yeah, so I was a student doing computer science at the time, and so when I was looking for a internship position, Inquisitive Intel was the spot for me. And at first, I was like so out of my depth because I'm like, I'm a programmer. What am I doing investigations? But it's funny the overlap that you find, being able to like traverse the web and find little like loopholes and stuff in digital evidence. It's very weirdly related. And then while doing that, started to work on the tool for internal use, and that was kind of like my primary role was just getting this tool complete. And I kind of hit the bottleneck that we found and just kind of started this.
Very cool. Well, I mean, it's great to have you guys and your breadth of experience in crypto now. So I'd like to maybe take a step back here and talk somewhat about decentralized storage. We mentioned a couple of products out there, but back in the day there was this product called Storage or Storage that a lot of early folks will remember. Then Saya, I think they're still around. And of course, IPFS really, I think, created a brand new way of doing decentralized file storage and was quite innovative at the time, and probably I think now captures most of the market. Of course, then we have Arweave, which took it even a step further and offered a permanent storage solution with this endowment that ensures that the cost of storage is insured over time. So there's quite a few solutions out there, and I think I'm probably missing some other ones that I'm just forgetting right now. But yeah, what does the market look like in your view? Are these products comparable, and do they serve the same use case, or are they sort of purpose built for specific types of applications? And where does Jackal fit in all this?
Yeah, that's a great question. So when you kind of look at the competitive landscape, let's call it, of data storage in Web3, first thing first is IPFS. What is IPFS? It's not really a storage layer, but it's more of a discovery layer. It's a way for you can index content by ID rather than location, which is really interesting. And Protocol Labs, when they were looking to build a storage layer for IPFS, they built Filecoin. And a lot of these storage networks, they were built back in kind of 2017 ICO era. And they kind of also had the tech stack decisions where they were using the state of the art back then. And they haven't really been able to pivot from that because it's really difficult once you kind of choose proof of work, and then you get all these people to buy these really expensive servers, and you kind of run down this product path that was an informed decision back then. When you look at it, everyone's kind of in a weird category of one in our mind. So you have Filecoin is primarily cold storage, archiving, putting data to rest for a really long time. If you want your file back, it can take up to 24 hours. It's a marketplace based, so it's more of a like matching buyers and sell and like service providers of storage, rather than kind of being more of a kind of like a SaaS product that we're used to with like a Google Cloud or an Amazon. Arweave's a little bit different. They're also proof of work. They have like this Blockweave technology where it's a little bit different. Then again, it's still kind of like this cold storage archiving, putting data to rest. And all of the players currently right now, they built on these proof of work rails, and they kind of go in the category of like vertical scalability, right? So if you want scale, you have to like kind of build an L2 and an L3 or an L4. And that's the direction that they have to go based on the tech stack decisions that they made at the time. Interoperability is not really an option for them at the chain level. If you want to kind of like interoperate with other blockchains, they can't really do that. And that's kind of the state of the market, of like the competitive landscape across the board. What we wanted to do is kind of take a different approach. We have proof of stake speeds, we have modular blockchains now, we have IBC interoperability, and we have the opportunity to build a product that isn't really a cold storage archiving product, but actually a foundational kind of hot storage layer for blockchain applications. So we can build full stack apps on blockchain rails. That being said, we had kind of almost want to say like a last mover's advantage in a weird way, where we were able to kind of see the landscape, see where everyone make their tech stack decisions, and then make our decisions based on all the information that we had at the time. And that's kind of a competitive landscape if you want to look at it. But Marston, do you have anything to add on that?
Just kind of like at a fundamental level with the way that these existing blockchains were working is things like Filecoin were really, really great. You've got kind of like this data sealing process, which made the speeds really exciting, made the data availability really exciting because it was proven over and over and over again. And it was a really advanced step forward in trying to minimize the amount of work that the blockchain was doing. You had to seal all your data. That was kind of like, as Patrick mentioned, kind of the state of the art at the time. As time's gone on, when you look at things like Siacoin, they limited a lot of their bandwidth and how big the file chunks were that were being proven for this exact same reason. We're at a point now where blockchains have gotten so much better, even just like at a core level, that optimizing for very specific things is still important, but we can get away with doing a lot more on a lot less because of the way that we're processing a block every 6 seconds instead of every 5 minutes. So the amount of data we can funnel through those blocks are a lot higher. And what we're left with is just a really scalable, really fast data storage layer. Pair that with a lot of the advances in proof of stake, where you've got like interchain security and the like. What you can start doing is once you scale out of your own block space, you can start creating these like subnets. And those subnets aren't any different than the main chain that's running, but they're all running off like interchain security from that main hub. So now you're left with this really horizontally scalable environment that just wouldn't be possible without IBC.
Just to add one more thing to that, it's kind of the modular versus monolithic thesis, right? Let's say that like I'm a builder on Arbitrum. I want to have the ability for me to use decentralized storage for whatever application I'm building. Let's say it's like a social app. Just because of the way that these monolithic chains are built, my options are I choose like a Amazon pinning service and I pin to IPFS myself, or I use a centralized solution to like run an API. Other option is that I leave and I build on top of these monolithic storage layers. So I actually have to leave my community, leave my liquidity, leave all the benefits of building on like a general purpose L1, and I have to move my entire application. We think with the kind of development of IBC, now we have the opportunity to deliver the functionality of Jackal to all the chains and provide value rather than kind of fight in a zero-sum game for devs and users, which is a little bit interesting. So it's a little bit different of approach, but at the end of the day, it's really just the monolithic versus modular debate, but on the storage scale, I guess would be a good way to put it.
No, okay, understood. And we'll talk a little bit more about interoperability and how this all fits in the modular thesis in a little bit. But first, I wanted to get your thoughts on why people are so excited about these sorts of products now. DePIN, like what is? I mean, DePIN's been around since. I mean, if you consider Sia and Storage A and all these projects as DePIN, why is DePIN so hot right now? And what do you guys think of this whole narrative?
Yeah, I guess if you build for long enough, the narrative comes to you. I guess that might be the thing. But I think there's kind of been a reason why DePIN hasn't been the flavor of the month for a long time. Number one is when you look at these DePIN networks, they're multidimensional. That being said, it takes like multiple things to get right in sequence and working in harmony for you to even provide like a minimum viable, let alone sellable product. This is interesting because it takes a long time to build these things. It's like comparing like Snapchat to Boston Dynamics when it comes to the complexity of what you're building, right? It doesn't mean they're necessarily like a better business model, but it definitely means that it's a harder thing to build. And when you build a really hard thing, it takes a long time to build it and deploy it and have it really working at scale in general. So I think the timing is associated with where blockchain development has gone. The teams that are kind of being the winners of the DePIN have been building for a long time. We've been building for almost 3 years now, and we're just starting to find like a taste of product market fit now. So it's you have these multi-dimensional products. You have, like, for us, we need the storage layer, we need the blockchain, we need IBC to function, we need all of our algorithms for redundancy and detection of loss, we need cross-chain outposts, and all these things just working perfectly together before we can even get one thing right. So I think it's just kind of a question of development time and the differences in complexity of different applications. If it was a DEX or something a little bit more simple to deploy, they're really easy to build, find product market fit really quickly, and just kind of have the ability to just scale right out of the box, rather than these things are a little bit more complicated, take a long time to build. And that would kind of be my answer to DePIN and why now.
Yeah, no, I think that makes sense. Let's talk about the product. So, how does Jackal work, and how do developers interact with it?
Of course. So at a high level, you can kind of look at Jackal as two peer-to-peer networks. You have a blockchain, and then you have a storage layer, which is our second storage peer-to-peer network. At the end of the day, the blockchain and the validators, you can think of them as the police of the networks, as like who has what storage deals, what storage provider have what files, who has access to what files, maintaining redundancy and making sure that everything runs smoothly. The storage providers, as a separate peer-to-peer network, they store files. They store encrypted data of users, and then they submit attestations to the blockchain via, we have some off-chain consensus with things called consensus spheres that Marston can get into, but that's kind of at a high level how it functions. So basically, you show up to the blockchain, you tell the validators, hey, I want to store this file, update my file tree, create storage deals, and just one click, sign one transaction, and away you go. Now your file is being stored. Jackal was a little bit different than other storage layers in the sense that most of them were marketplaces. And what we look to do is we see our blockchain more as a SaaS application. So you pay per terabyte per month of storage. It's kind of like a prepaid debit card at this current moment until we get streaming subscription payments through wallets. But let's say I want to store this file, I can store for a month, I can store for 200 years, and I just pay that transaction, and then the validators take care of your file, so you don't have to fumble around encryption keys, manage your storage deals. You can just set it and forget it. So that's kind of a really nice thing about working with Jackal. But on the development front, I guess, Marston, if you want to get into the difference between developers on our chain versus how we look to provide value to developers on other chains, I think that would be great.
Yeah, I think kind of one of the big things that we kind of really prioritized early was the ease of use for front-end developers and library developers to connect straight to Jackal. When you're looking at something like Filecoin, for example, you have to upload your file to a node on that network. That node then has to kind of make that deal on your behalf, so then you end up paying that node. It's a very complicated process to go from starting a file upload to getting your file on chain. If you look at Storage, they use central nodes to kind of distribute that file out. Our goal from the very beginning was to have the users talk straight to the storage providers. We sacrificed some of that kind of sealing time like Filecoin was doing, made it a little bit more heavy on the providers. But what that allowed us to do is it allowed us to have the user's web browser talk straight to a storage provider and upload that file straight to them after making that deal on chain. The storage provider goes, okay, I know you've already made that deal. I'm good to accept this file. But the upload is straight there, which really makes it feel like a traditional kind of Google Drive application where that user isn't going through a bunch of hoops. They're not watching their file get uploaded, and then it's off their machine now, but now they got to wait for it to upload somewhere else. So that was a big hurdle for us to get over, was just kind of that ease of use on the user. What that allows us to do in the IBC is even more special because we're kind of circumventing that whole middleman. You just upload it straight to the providers. If you go and say you're on Archway and you make a storage deal over on Archway, that storage deal through interchain accounts makes its way back to the Jackal protocol. From there, that deal is on the Jackal chain. Same thing. your client just uploads that file straight to one of the Jackal storage providers. Archway doesn't need to have its own kind of middleware that you upload to that gets passed over to Jackal. The files circumvent that whole chain layer, which allows us to keep that user experience no matter if we're on Archway, on our native chain, or any other blockchain in the ecosystem. All your file uploads will feel like exactly the same because it's all going to the same place with the same amount of hops, which is really, really exciting for us. Makes user experience far more deterministic, so that like that user knows that they're using Jackal exactly how they want to be using it every single time.
Okay, cool. So let's maybe I'd like to propose an example here. Imagine we have something like Stargaze. I think they're currently using Pinata, which uses IPFS, but in an ideal world, they're using Jackal, and you're uploading your NFT collection, and it's going to get stored on a decentralized storage because otherwise, like, what's the point? Then, so you create your collection. You create that collection on Stargaze, so there's transactions being executed there. So you're interacting with the contracts on Stargaze. Then I guess there must be some kind of an SDK that you guys provide that Stargaze can then sort of integrate within their front ends that allows users to just upload directly to Jackal, and so that SDK then connects to Jackal nodes, makes the deal there with the service with the storage providers, and those files get uploaded directly, sort of circumventing Stargaze completely, and then I suppose sends back that data to Stargaze in sort of a callback so that it can be then kind of indexed in their blockchain. That's the reference to such and such a file, etc. Is that
is exactly
right?
it? Yeah.
Okay. And how does like the SDK, what is it interacting with directly? So when you're doing that upload, that file upload, so you've got a browser, you're uploading a file, right? Like it's getting sent to some API. Is that API kind of peer to peer with the storage provider, or is there a gateway in between that's facilitating that file transfer?
Yeah, so it is directly straight to that storage provider. So if I'm on Stargaze, for example, I submit basically like a request for a deal straight to the Stargaze chain through that interchain accounts module that we're currently in the process of deploying to like Archway and other networks. So what we're doing is Stargaze gets that deal request. That gets kind of forwarded through interchain accounts to the Jackal protocol. Everything gets settled there. Once your client checks on that deal and says, okay, yep, that deal has made it from Stargaze to Jackal and it's sealed, it's all good to go, then it allows the user on their client, whether that be a JavaScript front end or whether that be like a Golang server system, they can then just send those files straight to the storage providers of their choosing. Those storage providers then say, hey, I got that file. This is the proof that I have it. They send that to the Jackal protocol. And then because that reference is like saved on the Stargaze chain as this deal, anytime Stargaze wants, or a user can go to the Stargaze chain and they can reference data that exists over on Jackal, and then they can go and check it on those storage providers directly without even needing to query the Jackal chain directly.
That's kind of what's beautiful, right? That's really what's beautiful about this is that every blockchain, if they're IBC connected, have this functionality. So every blockchain can have the functionality of Jackal, where simple smart contract call, and then you have the ability to store data, and you have scalable storage at the chain level, which is just such an important just layer of the stack when you're building full stack web applications, whether it's Stargaze and NFTs, or whether it's social or decentralized science, or people starting to play with AI and ML use cases. At the end of the day, it comes down to we need just such a core functionality for scalable storage. If it's over whatever you can fit in the blocks, which is some data availability networks, they let you do like 3 megs. A lot of other chains, like it's like a few kilobytes, so it's whatever you can fit in the tweet. It's really important for us to have web scale applications on these blockchain rails if we think that this is going to be successful over the long run.
No, that's really cool. I can think of all kinds of applications here. I mean, if we look at something like Farcaster, for instance, that is storing data somewhere and could leverage something like Jackal to save images, videos, text. I tried to build a blog on Arweave, was unsuccessful. Like my dream is that my dream. I'd love to have some kind of like a decentralized blogging platform that I could use and like stop paying for some like WordPress thing or some, ghost hosting, and just be able to dog food this technology in a very simple, application, which is a blog. So if anyone's building a blog for Jackal, like I'll use it, and like we'll put our website up on there. But yeah, like these are the kinds of applications that I, as a former web developer and guy who likes to tinker at things, I like to play around with, and I think are just really easy sort of demonstrable use cases. Like I set up, I used Akash for a while to set up a couple of websites. I was like, this is super cool. Like, I mean, I don't have to go and create an Amazon account. I just like send some tokens here, and I like, here's my website, right? And so I love this kind of use case, and I think they're very easy also for people to understand. Beyond the okay, let's store some NFT files, or like let's do some crazy, LLM model storage and stuff like that. Like the simple use cases are easy to create and to understand. What's the role of the Cosmos SDK module? So we describe here kind of the workflow. We're leveraging interchain accounts to be able to make cross contract calls. Do chains that want to leverage Jackal storage have to integrate this Cosmos SDK module?
Not necessarily. There's kind of a few things that we've got going on right now where the core model is, yeah, as you say, you do a chain upgrade, you throw in that interchain account controller module into your blockchain, and then you're good to go. People on your network can start using Jackal over IBC.
Okay, so there is a network upgrade required in order to kind of enable Jackal on your chain.
Only if you're going down that route. We have the other side of things where if you already have Cosmos on your chain, you can deploy a simple smart contract, which we've been working on for a few months now with Serdar from the ICF. And what that basically allows you to do is no chain upgrade required. It just boots up, it manages everything for you, and it is a full interchain account controller. So any Cosmos enabled chain that exists can become an interchain account controller on Jackal without needing to do a chain upgrade, which is really, really exciting. That distribution layer really opens up.
Sense, yeah. Yeah. Okay. So the module exists for chains that don't have Cosmos. I guess in the future, a lot of chains probably have Cosmos. What about EVM chains? How can they leverage? I mean, I guess they could integrate the Cosmos SDK module, but is there also a way to do this with an EVM contract?
Yeah. So that's something that we're it's theoretically possible right now. It's just managing to get those kind of like IBC calls over EVM right now. I know like Evmos does EVM, so we've been chatting with them a little bit to see how we could kind of integrate there. As far as getting over to like traditional kind of existing EVM chains like Ethereum or Arbitrum, that's kind of up in the air right now, where we've been chatting with like teams like Union, who are kind of pioneering that IBC connection to Ethereum. And once we see kind of those things mature, I really guarantee that it would be as simple as posting a Solidity contract onto Ethereum to get those IBC calls going over to Jackal in almost the exact same way that we're doing it on Cosmos right now.
Got it.
It's like IBC is kind of like our distribution in that way. Everywhere IBC goes, we go, and we're pretty confident in IBC's ability to be that standard for bridging, whether it's tokens or getting arbitrary data between chains. Obviously, we have backup plans if in the event that IBC doesn't go everywhere, which we think it will. We could also use like Axel or GMP, or we could build our own solution as well.
There's also this proof of persistence algorithm that you guys have built, and I guess this enables users and applications to verify that a file still exists. How does that work, and how do the storage providers ensure that files are like still being stored on their servers? And maybe also talking about that, like what's the redundancy here, and how does that play into this?
Yeah, at a high level, basically, we didn't want the end user to have to manage their storage deals locally, and we wanted them to have ownership of those files. So for our ability to do that, we needed essentially the chain to manage the redundancy and manage the encryption keys on the behalf of the user, which is pretty fascinating. So essentially, when you go and make a storage deal with Jackal, the validators will spit out 3 storage deals to 3 different storage providers. Your file will be sent to one provider. It will stay there. Once it's downloaded, essentially the 2 other providers will start copying from redundancy to ensure that we always have 3x redundancy on the network. let's say that one provider says, "Do you know what? I don't want to be a storage provider on Jackal anymore." Or like let's say their electricity goes out or a natural disaster happens or tsunami or something. In the event that that happens and then that storage provider stops submitting attestations to the blockchain for a specific file, the blockchain will assume that that provider has either lost that file or it's corrupted. When that happens, the validator set will break that storage deal with that provider and then send out a new one to another provider to actually make that deal and then copy from the redundancy. So it's kind of like storage whack-a-mole in a weird way, where you kind of make the validators make sure that you'll always have redundancy on the network. And by having this in place, it gives us a lot more flexibility when it talks about like the sealing and unsealing process. But Marston, if you want to kind of do like a little bit of a deeper dive into like consensus spheres and how that process works on like the verification of the files to make sure that we always have them on the network.
For sure. Yeah. So at a little bit of a deeper level, every time a storage deal is made, we build kind of a tree. So we split all of the files into like 10 kilobyte chunks, and then we build a hash tree. So we take the hash of each chunk, hash it with its neighbor, and then go up and up and up and up until we reach that root. That root is the only thing that's ever stored on chain, which is really, really exciting because it means that we only have to store a little bit of data for an entire file. No matter how big your file is, that root will always be the same size, which allows us to store like 10 gigabytes in the same kind of space that we'd store like 1 kilobyte.
So just stop in there for a second. Why do you cut up the file in chunks? Why not just make a hash of the file?
So if we wanted to make a hash of the file, anytime we wanted to prove that file, we basically have to create a proof that we know the entire contents of the file, which can take a really, really long time if that file is like 10 gigabytes. What we do instead is we, over the course of time, randomly pick different chunks to prove. And we kind of lean on statistics a little bit to say that if you're proving a random piece of that file every 6 hours, after, 10, 20 of those rounds, it would be very economically unviable for you to only keep the pieces that you want and then move the other pieces out kind of thing. So that allows us to prove very, very small pieces of data over and over and over again, instead of proving very large pieces of data like once a month. So that's really.
Why not use erasure coding here? Like, because Celestia has also does this, right? Where you are able to prove that data was posted by verifying just like small pieces of data on the chain. Is there something here that prevents, like, does file storage as a use case kind of prevent that technology from being used? Or yeah.
No, so erasure coding is kind of like one of those things that we have kind of down our roadmap. Right now, what we're trying to do is really build this like general purpose storage. So if you want to store files directly as is, you can do that. If you want to store files that have erasure coding happening, so you have like 30 different pieces of the same file and you want to store it that way, that's totally something you can do as well. What we're building right now is that kind of groundwork to allow users to choose what they want, and kind of embed that erasure coding technology into the storage providers instead of the actual chain itself, so that nothing's hard coded into the blockchain. You don't need to do chain upgrades to enable that erasure coding. We have this really general platform where whatever data you give the network, that's going to be stored, that's going to be proven. So if that is a chunk from an erasure coded file, that's great. It'll do that for you, but it can also just store raw data.
Okay, interesting. And all the files on Jackal are encrypted by default?
Yeah, so you can choose to just upload raw data to Jackal. The protocol itself doesn't actually care what data is going up, whether that's encrypted or not. But all of our client libraries, our like server-side libraries, all that stuff, by default, it fully encrypts your stuff. We have a file tree module that manages all of your encrypted data, so that nothing encrypted is ever making its way on chain. Or sorry, no encryption keys are ever making their way on chain, but through a series of like deterministic signatures and all that good stuff, we're able to have a user unlock all of that encrypted data every single time they go to use the protocol just with their private key.
And that's really important because all of our decisions being such a low level to stack, we want programmability for the different use cases, right? So let's say, for example, a publishing application wants very different things than like a peer-to-peer file transfer application. For publishing, you just want public files. You want anyone to be able to go and look at that file through, like, let's say, a web gateway that we have Shepard, for example, so you can just publish data on the Jackal protocol. But on the flip side, some people want to use it like a private Dropbox, where you don't really want people to look at your wallet and see all your files. And having that programmability and having the ability to be malleable for different use cases has always been really, really important to us as an organization.
So I guess you could build a decentralized Dropbox with this, as you could do, like NFT storage, as we've talked about before. But could you also use Jackal for like general data availability for blockchains, where chains could post data? I mean, I guess sort of similar to how you would use Celestia.
Yeah.
Yeah.
I really like to kind of make an analogy that like a file is just a chunk of data in the same way that a block is just a chunk of data, in the same way that like a proof for a file or a block is just a chunk of data. So what we can do is with Jackal, everything is indexed on kind of the top layer of the chain, which means that at any given moment, if you request data, you can tell very quickly whether it's available or not, because it is sitting on the state of the chain rather than in historical data, like a lot of data availability layers are. So what we can do is, right now, if you're looking at traditional data availability for like rollups, you're posting the proof that that block is correct to that data availability network rather than the entire block itself, because posting that entire block gets very expensive. On Jackal, because that data is not stored directly on chain, you can post entire blocks, entire lists of transactions, big snapshots of multiple blocks together, all in these individual files. And then you can take just kind of that hash of that file, and you can store that directly into your rollup to say, hey, this is the block that we need. And so now we're getting into a state of the data is available on our chain because we have proofs running every like 6 hours. But we can also determine that that data is ready to be pulled off those machines, which is kind of even an advantage over traditional data availability layers that we kind of see today is you still need that data available somewhere. Even if that data is, stored and verifiable, you need to store it somewhere. And that's where that kind of gets tricky, and a lot of the wording around data availability gets really muddy, where Jackal, it's there, we can prove it's there, and other than that, there's really nothing more to a data availability layer for a rollup.
And it's kind of interesting, the integrations that we're looking to build with, for example, Jack from Strangelove and their Roll Chains application.
He was just on the podcast,
like
actually.
I know, he's an awesome guy. Because we're looking to do a few things with them. Marston, do you want to? Because like the earliest thing, obviously, is not necessarily using it as availability layer for the chain, but also like node snapshots and things like that, or the ability for us to integrate with them on that front. And Marston, like kind of like an MVP, what do you see like that looking like with Jack, for example?
Yeah, I mean, as you mentioned, there's kind of like a few things that we could do. The easiest step forward is just embedding kind of these Jackal outpost situations into new roll-up chains, so that day one they have the ability to store data to Jackal for their apps. So that's really exciting. Kind of as a more data available type system, having automated snapshots coming out of the chain, where that block proposer every 200 blocks, let's say, they just take a snapshot of the last 200 blocks, and then they load that onto the Jackal protocol so that other networks can just go and grab that data straight from there. That's really exciting. And then obviously, yeah, like that last step would just be full roll-ups running on Jackal, and using it as a block store instead of the validator set itself, which is, a lot of R&D, making that experience feel good. But there's a lot you can do with just raw data storage. It gets really, really exciting if you think about like how even Web 2 works. You have compute, and then you have storage, and everything happens in those two sections. And if you provide a generic storage layer, anybody doing compute, whether that be a blockchain, whether that be something like a Kosh, they can do whatever they want to that storage layer. Now you have a full working computer in the cloud, which is really, really exciting.
I mean, I've thought about this too at some point, which is, there's tons of compute in the blockchain space. I mean, execution is king. There aren't that many, like storage has kind of been left to the side. And I think that's why. I think that's because the majority of use cases for blockchains rely on like ownership of assets, and those don't take a whole lot of data. Like, I mean, you don't need a whole lot of storage to track the ownership of those things. Whereas, storage is more complex because like with storage, you have this, well, you have the problem of also the size of the files and just the amount of data that needs to be kept. And then like the redundancy. And then on top of that, like the kind of perpetual nature of blockchains that where like files need to be stored for a long time. So that's a really hard problem. Like, I think the reason why we haven't seen, very many use cases that leverage on-chain storage or decentralized storage is because it's a hard problem to solve. And for the most part, I think a lot of the applications that use lots of storage can don't need to be kind of perpetual. I mean, there are applications I think that could be perpetual, could benefit from perpetual storage, like things like ancestry, all sorts of scientific data, social networks. I mean, who cares, right? Like, who cares if our tweets disappear? I wonder, on the use case side, what are the most exciting use cases that you guys have seen in the sort of crypto native side of things, but also just in the regular old data storage use cases?
Yeah, it's kind of interesting because a lot of people, the value proposition of Jackal is different in a lot of people's minds, right? So let's say that, for example, we have a telecom company in Iowa that uses Jackal to back up all of their user data because they have legislation that they have to do that. And what do they care about, right? They don't really care about decentralization or ownership or a few things that just all like the core ethos of blockchain technology and our communities. They don't really align with that. They want SLAs and they want all that stuff. But that being said, what they do really like about Jackal is they get geo-distributed data that's verifiable and auto heals. If you want something like that with Amazon, just geo-distributed data in general for like, let's say a terabyte, you're looking at almost $200 if you want multi-region storage per month per terabyte. Jackal is doing the same thing at $8 a month per terabyte, which is pretty fascinating. So like they see it as a competitive advantage for the verifiability. They also see the geo-distributed nature as their value proposition. Web3 storage, they care about different things, right? Until very recently, we haven't had the technology to actually provide a good user experience in an active cloud environment, even on blockchain rails. So everything has kind of been more of like backup to Filecoin or backup to Arweave and have an archive there just so that they can hit the buzzword, but not necessarily because they actually want to use that application. Very recently, we've had the technology advance. We have IBC, we have proof of stake, we have speeds, we have the boring cryptography work that's happened over the last, let's say, 10 years. We're starting to get to the point where it's actually almost at cloud parity. We're not quite there yet, but we're getting pretty close in that sense. And if you're building an application over there, what do they care about? They care about, well, integrations. Can I just call a contract and have it work? Do I have to manage my storage deals? Do I have to manage my encryption keys locally? Do I have to do all these things? They care about the ownership, the sovereignty, the decentralization, and the ease of integration, and is it blockchain native for their application? Can I just embed it very simply into my application? So that's what they care about, right? And then that's kind of like the B2B Web3 front. And then there's also like the end users in Web3, like all of our 930 people that use our Dropbox type solution right now. They just use it as like, I just like privacy, sovereignty, security. I want to own my data in the cloud environment where I'm only the end user with my private key has access to this, to my file tree and my files and all that stuff. So they kind of just see it as like a Dropbox, which is pretty interesting. So it's kind of malleable and it kind of pivots into a lot of different use cases, and there's a lot of different value propositions with the protocol in general.
Yeah, I think one of the coolest things that is coming out of this kind of decentralized storage, it's combining a lot of technologies. So if you're looking at something like homomorphic encryption, getting fully homomorphic encryption running on top of Jackal, kind of just as like a drop-in replacement for the current like AES implementation we have for certain use cases. I know the Zama AI guys they've been doing a lot of really cool stuff with homomorphic encryption and kind of pairing that with AI model training. And so what we're kind of looking at is these big data sets that you want to kind of train an AI on. What we're kind of looking at now is this, you can homomorphic encrypt it, send that off to a company that's running an AI training so that you don't have to have all the hardware yourself. And they'll never know what that data is, and they can return you a full AI model that they never even know, they can't even use it because it's fully encrypted to your keys, which is really exciting. The thing that it got me thinking immediately when I saw that is that data needs to be somewhere. And having that data stored securely on a decentralized platform like Jackal, you start pairing these different technologies together where you have, your data encrypted on Jackal, and then you have this like secret AI training running in like an Akash compute module. You've got a fully private end-to-end system where the user can upload their data, it's their data, they train their model, they own that model, and nobody in the supply chain ever sees what that data is, which makes it really, really secure, really, really private. And those types of like combinatorial technologies working together create this really, really nice use case. And I think Jackal fits in there really nicely.
Pretty cool. Pretty cool stuff. At the end of the day, we're obviously pretty excited from that side. Just like it's like this, it's like self-hosting, but the scalability of the cloud. It's like full ownership. It's like no different than having your files in your desk drawer, but you still have like this beautiful scalability where only the end users access. Like we can't even access it, and we built the thing, which is pretty cool.
Yeah, I mean, I think that's one of the most important properties here is that everything is trustless, encrypted with a protocol. You can use the protocol in a full trustless way without the team having access to the files. I'd like to talk a little bit about the tokenomics and economics of perpetual storage. When I first heard this, I think when we interviewed Sam from Arweave on Epicenter, I thought it was sort of crazy that you could pay once and have perpetual storage. It sort of breaks the economics of most things that we're familiar with, right? Where like you usually pay for something as long as you have it or as long as you're using it, not like a one-time payment forever. If you could describe how the economics of Jackal works with regards to the perpetual storage solution, but also like the dry storage solution where files can exist for like a predetermined period of time, or at least not in perpetuity.
Yeah, and before I hand it off to Marston, there's forever's a long time, right? And it's making a lot of assumptions with a model like that. We like to kind of have the authenticity of saying exactly what it is. So if you want storage on Jackal with our perpetual storage option, we say 200 years because that's what we can guarantee without any just models of just predicting like what the cost of storage will be then and predicting that drives will get more efficient and having all those associated risks with that. We like to kind of make sure that what we are saying is actually going to be delivered. And with that, I'll kind of pass it over to Marston on how like 200-year storage works in general.
Yeah. So, I mean, as Patrick said, we take a very, very different approach to Arweave in regards to kind of our perpetual storage, where we price it out exactly as we kind of expect it to be priced. So if we're charging $8 a month per terabyte, if you want to upload a terabyte for 200 years, it is $8 a month for 200 years, and you just pay that up front, and then we drip feed that out to the storage providers exactly the same way that you would if you were paying monthly for an account. Arweave makes a lot of assumptions on the fact that like data will get cheaper over time, and that's why they can price things out the way they do initially. We don't really like to make that assumption. There's, it is the case right now that data is getting cheaper, but if data ever didn't get cheaper, all at once, kind of a protocol that makes those assumptions kind of starts being unprofitable for all the storage providers at the exact same time. And that's the thing with like economics of everything. You cannot fully predict everything. Nothing is perfect. Even Jackal, if we're pricing everything out at $8 a month per terabyte, if somehow data hit $20 a month per terabyte for the storage providers, well, then it's not profitable for them either. We kind of just assume that, it's not going to get cheaper. It's not going to get more expensive. It's just kind of going to stay exactly as it is. And if it gets cheaper, that's great. If it gets a little more expensive, the protocol will kind of take that hit. Too much one way or the other wouldn't be great, but that's kind of our philosophy on those 200 years, where we just price it exactly the same as any other storage. Already, we're doing that 3x redundancy, so that $8 a month is really covering a terabyte times 3 for all that redundancy. So you're already getting a pretty good amount of storage for that time. But for like those 200 years, if you're storing the same thing on Arweave, it is a little bit more expensive on Jackal, but it's because of the fact that we're drip feeding it out almost the exact same way that we would if you were paying monthly. And we really try not to make any assumptions on speculating the price of data storage.
I mean, here's like something that I'd like to maybe double click on. So in terms of data, data storage costs, I guess you could say are, like linearly declining, but are somewhat of a fixed, right? Like the cost of data storage, you could probably create a model for predicting the price of data storage that would be mostly accurate. However, the price of the Jackal token can fluctuate based on all sorts of external factors. And can you explain basically how you can? Because I mean, you're sort of basically assuming that the price of the Jackal token, maintains itself in a way that that validators want to continue running the chain. I mean, data providers need to want to continue storing the files, but also the chain has to continue existing. How do you guarantee that, like, in 5 years from now or 50 years from now, people will still want to validate this chain? I think that's sort of like the first thing. And that really, I think, creates a big dependency on the storage providers, whether or not they want to accept the Jackal token as payment.
Of course. The way that we do the storage payments is we saw it. We want users and businesses to make informed business decisions about how much the storage is going to cost. So that's kind of why we've moved away from a marketplace based, and we don't really the fluctuating price of the Jackal token shouldn't affect your storage in the sense that we built an oracle into the chain to peg the storage, which is governed by governance, to $8 a month per terabyte with 3 times redundancy. That being said, it kind of creates this interesting economics around the token in the sense that it's kind of like a call option that makes an assumption that more storage will be stored on the protocol. If there's no storage being stored on the protocol, then the value of the token goes down. Therefore, there's no use of running the protocol anyways, which is interesting in that front, right? So whether it's 1,000 tokens or whether it's 200 tokens for an $8 a month payment for storage, you're still going to be paying $8 a month per terabyte for the storage user and the business's perspective. Regarding security, we see security in a bunch of different ways. And obviously there's kind of this systemic issue across Cosmos where we have to have really high inflation to pay for security when you're in the bootstrapping phase. And there's also, I feel like a lot of chains stay in that high inflation period for a really, really long time, much longer than they need to be. And we have made the decision in Q2 with our economics upgrade. We're moving more towards a real yield / like kind of like low inflation model where it's a little bit of a hybrid where you can see the inflation as kind of like a universal basic income for the storage providers and validators. And then the real yield is deterministic on how well is the protocol performing from a unique amount of data being stored. On the security guarantee front and all the things that we're looking at right now, Marston, I know you have a lot of thoughts about kind of what's required for security in Cosmos, and like obviously like we're talking with Babylon and things like that, but I'd love to hear your opinion because you have a really interesting take when we talk internally about this.
Yeah, I mean, so as far as like making sure that the storage providers are maintained, Patrick said we're kind of going that real yield model where we're moving away from just accepting Jackal tokens as payment as well. So we'll start taking like USDC. So the storage providers will guarantee that their income is their income no matter what. And they're probably going to end up getting a basket of different tokens, whether that be like Atom, whether that be Jackal, whether that be USDC. So that kind of pulls away the dependence on the Jackal token for storage providers to keep their incentives going, while still kind of bringing value to that Jackal token by having users pay for that pay for the storage as well as a bunch of other things, like our name service and all that in that token. On the validator front, they're still making a little bit of inflation in the new econ model. But the main thing is that they're also getting a portion of all of the storage deals that are being made. So if you're buying a month of storage, the validator set and all the stakers get a little bit of that too. So we're bringing that kind of recurring revenue back to the stakers and the validators. From that's in our mind, at least according to the econ model, like enough to keep the storage providers and the validators up. And as the chain gets more and more users, everybody makes more and more money. It's kind of an incentive model for those validators as well as the storage providers and even stakers to go out and try and get more people and businesses onto the network, because that means they make more. So you can kind of think of the whole network as like a software as a service company, which is really, really cool. Security wise for that validator set, I'm really big on the Bitcoin security and the timestamping through like Babylon. I think that's a really, really great use case for Bitcoin. It kind of creates this really big economic hurdle for people trying to attack the Jackal protocol, because now they have to attack Bitcoin as well. And so you pair that with kind of potentially trimming down the validator set, making the validator set cheaper to run, bringing that real yield revenue, and then worrying less about security from a tokenomics perspective, because you've got that Bitcoin security. You create a really, in my mind, this very sustainable validator set paired with the storage providers. It creates a really kind of like harmonious ecosystem.
Okay. Yeah. I mean, I think there's lots of different avenues here to reduce the cost of the validator sets, obviously like Babylon, but then you also have, roll chains or Ethos, which will be live this year. So I think the options for running a chain more efficiently and more cheaply while maintaining a high degree of decentralization and security are becoming more and more. I mean, there's more and more options available, and I think we'll see by the end of this year probably a few of those go live and be used in a number of chains. And I know there's already protocols in Cosmos that are considering drastically reducing their validator set, and chains like Noble, for example, that are already POA chains are going to become more decentralized by using roll chains and posting data to Celestia. So it's all very exciting. I think it's all positive for Cosmos chains that, in all honesty, are very expensive to maintain, and there's a lot of inefficiencies there as well, right? If you look at the, I think it was Sunny who posted this at some point, but he had this chart that showed the overlap between validators on different chains. I mean, there's no reason why then chains need to kind of inflate their tokens in order to pay for security when you could have something akin to mesh security that would really reduce the cost of security across the entire ecosystem. Before we wrap up here, I wanted to talk a little bit about interoperability and IBC and sort of how that ties into all of this. We mentioned it a little bit, but what are the applications that IBC combined with Jackal unlock that you find the most exciting?
Ooh, that's a good question. Like right now, we look at pretty much every application needs storage for something, right? And the question is that where's like the best return on investment for the development time is the decision that we have to make right now. So we see a lot of different applications, whether it's like AI ML use cases, which are interesting with Morpheus and Orion chain. Like they want things like checkpoints. They want their AI agents to not have dementia, so they remember things and things along those lines. So those are really important. NFT use cases are cool. But the thing that I'm most excited for associated with having like a scalable and fast and actually usable storage layer in general, whether that's in the Cosmos ecosystem or whether that's using IBC to go beyond the Cosmos ecosystem, is what can we actually build now that's not already being built on blockchain rails because of this limitation? So I'm looking at things like peer-to-peer file transfer, like sending files anywhere in the world peer-to-peer without middlemen. You have functionalities where you can do DeSci projects where we have Abacus they're like storing human genomic data in a self-custodial way, which is interesting for their science application. The possibilities are endless. Social applications, other just web scale applications that we want to build on blockchain rails and people have tried and have failed. Actually having like a good user experience and the speeds that we're used to and having cloud parity. Obviously, takes time for us to get there. We're going to be a little bit slower than a G Cloud because we have to encrypt the files if you want encryption. So like it bloats them a little bit, so it's a little bit slower. But most of that is UX issues and kind of communicating with the user on that front. But Marston, what are you thinking? Like, what are you excited about overall?
Yeah, I mean, we chatted about it a little bit, but IBC opens up a lot of possibilities for a kind of just generic applications, whether that be an NFT, you're going live with a 10K PFP, all of those are, you're able to upload those straight from whatever chain you're hosting them on. That's really cool, makes the UX a lot better for that. There's kind of the other route of like more kind of web 2.5 layers, like, NFT marketplaces or data marketplaces where, they're not actually running everything on chain because they have all these indexers and everything going in the background. They can store a lot of like backups and a lot of that user data that wouldn't necessarily need to go on chain anyways, but they're still kind of in that Web3 space. You can do all that straight through whatever chain, again, you're hosting everything on. So, those kind of big data applications are really cool. And then I think what's going to be really, really exciting is it's not something that's currently really done anywhere. We kind of been talking about it with the data availability stuff, is like, if you can access storage on any platform and that storage layer is accessible on chain through like data agents, no other platform can actually access that storage data directly on chain. With Jackal, because it's so modular, you're able to kind of use like data agents to go and fetch data from an actual storage provider and then post little chunks of it to the chain using those like Merkle tree proofs again. So it becomes very secure, very fast. You can kind of, look at chain data from any other chain. What that allows us to do is it's kind of extends beyond what's currently possible. And I don't know if there's, a really good use case for it, but imagine, you're running a roll up and you post all of the block data in individual files to this network. Imagine running a smart contract on like Juno and being able to access the block data from a smart contract of an entire rollup and then be able to like run, whether that be token transfers or anything based on the data that you're seeing in those blocks as they come in from another network. Now you're communicating at a core level that's like never been done before in Web3. And so things like that really, really excite me, where IBC opens up all these possibilities that we normally wouldn't have before, which is really, really exciting.
And that's great. Like I also like the most complex, like obviously like data agent, smart contract read and write to off-chain data storage is pretty huge in our opinion. And we're excited to like kind of aiming like Q4 for this functionality, which just kind of makes like decentralized APIs in a weird way. But the other cool thing is sometimes when we look at Jackal, some of the use cases that are killer are also like the simplest in a weird way as well. The one that we've been talking to a lot with organizations is with ledgers, for example, right? Own my files, own my tokens, self-sovereign. But the functionality of just something as simple as like ransomware backups to make sure that if your organization gets hit with ransomware, you have a backup that's air-gapped on a multi-signature wallet that controls the root folder. A board of directors come into consensus to unlock their files. That means that a hacker, if they want to completely cripple an organization and they need to get all the mission critical data, if you're using like Jackal as a backup solution to protect yourself from ransomware, they'd have to physically harm like 60% of the board to get their private keys, for example, right? So functionalities like that, where you have like this new level of like the highest digital privacy and cybersecurity posture possible in a cloud environment. So you still have that scalability, and having a service like that where it's so secure we can't see it. It's that's the beauty of it, right? It's such like a low level of the stack, really valuable. I am sure that there's those kind of things that people are going to build that we don't know about either.
Man, I just want something simple. I want like a blog and like decentralized Notion. That's it.
Well, it's kind of funny you mentioned
we got
that.
Beacon.
We do have an alpha of Beacon, which is our kind of blogging platform.
Yeah, I played around
with it. Check that out. Yeah. It's as we say, it's still early days, but it really does. There's no centralized third parties. It's just you upload everything straight to Jackal, and it's a fully kind of MVP of a blog platform, which is somebody out there could probably spend more time on something like that and make it a better UX. But yeah.
I'm looking forward to playing around with these early products and tools being built on Jackal. Where can people find out more about Jackal, and potentially, if someone's interested in starting building on Jackal, where can they go?
Of course. So the best way is to kind of come and follow us on Twitter, come to the Discord. We have Telegram as well. So that's kind of where most of our community, we're a little bit more active in Discord than we are on Telegram. So that's probably the best place for it. Outside of that, if you want to come build directly on Jackal, that's awesome. But what I'm excited for is us building our outposts on other blockchains. So if you're a builder on Archway, pretty soon you're going to have all the functionality of Jackal there. So we're excited to also providing Jackal to other development communities and giving them a toolbox of all kinds of stuff that they haven't had previously, which is super exciting.
Cool. Guys, thanks so much for coming on.
Thanks for having us.
Appreciate it. Thank you, Seb.